I recently came across a series of articles about real-world programming challenges. Each article in this series has you implement a small library or program, which is fairly self-contained, small in scope, and should serve as a good introduction to whatever you want to learn. Each task is well laid out. Firstly, they summarize what you're going to be working on. In this case, we're working on the word count program. They give you some sample input, which is useful because all of their example outputs are run on this input, so you can compare as you go along and see if you're on the right track. Then we have a series of steps to implement to reach our goal. We're always summarizing our input, so the outputs are fairly simple. In the first case, we're counting the number of bytes in a file. Step 2 is to count the number of lines. Step 3 is to count the number of words. Step 4 is to count the number of characters, which I've taken to be graphemes in UTF-8 encoding in every case, just to keep it simple. Step 5 is that if no command line arguments are provided, we must summarize some of the outputs, namely bytes, lines, and words. Finally, we need to do all that functionality again, but taking standard in as an input instead of reading from a file. The command line arguments and the standard in, being the more practical parts of the program, typically were the most complex to implement. The actual summarizing and counting was pretty easy in all languages.
I had a few goals in mind when it came to this challenge. I wanted to implement the first version that came to mind, even if it differed between languages. I wanted to write in an everyday style, which means making use of the standard library, any available features of the language, instead of writing everything from scratch, because it wasn't that kind of challenge. It should function like a real command line program, with proper handling of arguments, using standard library APIs if available, but don't worry too much if they're not. And I didn't bother with any error handling like checking files existed. It felt out of scope for this. I just wanted to try and use this as a fun experience to learn a bit more about a few programming languages. So here are the players. In the first column we have languages that I've used a bit. I put over 5 hours for the sake of argument, but realistically I've used each of these languages for probably over 24 hours each. Out of all the languages listed here, Python's the one I've used by far the most, but I have written a bunch of D and Nim in the past too. Crystal, Clojure and C# are ones that I've picked up quite recently. In the middle column we have languages that I've tinkered around with in the past and written a few small programs with, but nothing major. Finally we have the languages I've never used before, including Factor, which is a stack-based language, and I have no experience with that paradigm, and Flix, which is a functional programming language similar to Haskell, and I don't have much experience with those either. I think this caused the implementations to, let's say, not be optimal. Here we have Python. I'll just show a few highlights from each of the programs. This is the argument handling in Python. It's a very nice API provided by the standard library. The only thing to note is this nargs equals question mark, which seems to be what makes the argument optional. Add argument does take a required flag, but that doesn't seem to do what you think it does. Reading both standard in and from a file is trivial in Python, as is decoding the byte string to a UTF-8 string. In this snippet and many of the other ones, I've omitted the control flow, which basically amounts to a few if statements, based on what arguments have been provided to the program. I really like the symmetry in the Python implementation, using len for each of the 4 counts. I think the consistency really helps the readability in this language. Printing can take variadic arguments, so we don't have to do any temporary string joins here. The Python version gets a 10 for easiness. This is with the caveat that I've written the most Python out of any of these languages, but everything was very straightforward. Documentation loses 1 point for the nargs thing. It wasn't really that obvious, especially with the inclusion of the required flag. Enjoyment gets an 8 because it's not the most interesting language, and I didn't learn anything, but it was nice to have a reference implementation. I can't complain too much because it worked out well in the end. This is my first time writing Lua. Despite that, it was easy to get up and running with the language, and it was one of the fastest implementations to write overall. I like the Virtesque syntax with no braces, even though that's just subjective. One thing to note about the language is it's very bare bones. It feels like a simpler version of Python, almost as if C were a scripting language. The table API seems simplistic. I only saw examples that used 4kV in pairs for iteration. You won't see anything like a list comprehension here. After all, embedding is the name of the game and they want to keep this language small. Also, Unpack has a different API between Lua and LuaJIT. I didn't intentionally install different versions, but it's not a very big issue. This is an example of having to read standard in blocks. We take 16KB chunks from the input and append them to a string. There's nothing like a string builder, so I don't know if the concatenation is efficient. Both reading from a file and standard in feel very similar to Python though. Also, the *A is an interesting API for reading the whole stream in one go. I couldn't find a specialized split function from a brief search, but thankfully it has good support for regex. Again, we won't see anything like a list comp, so we're just using plain for loops. I don't exactly know how I feel about everything being a dictionary in Lua, which are called tables here, but it didn't impact this implementation at all. The prefix hash is a cute operator to get the length of a collection, and UTF-8 handling is built in, which was nice. Overall, the calculations are a similar style to Python here, where we use a length function for all 4 counts. Lua gets a 7 for easiness because it's bare bones. It's missing built-in functionality which you would expect a language to have, such as printing tables, especially since they're one of the primary primitive types. It gets a 6 for documentation because they're not docs so much as a language spec, which doesn't make it the easiest to pass, as they're not curated necessarily. It was easy to search for answers though. The language which seems widely used. It gets an 8 for enjoyment because I found the language itself elegant and was pretty stress-free to write. I do admire them sticking to their goal of keeping it small. Here's Raku. Destructuring and binding command line arguments in the main function felt pretty novel to me, and I do think it's quite elegant, especially for scripts. This even gives you support for unsupported arguments and showing a help message. It felt like it was possible to pack a lot into a few lines of code in Raku, so I added a bit of extra functionality where we only read the bytes if we want to output them. That means we only read in binary mode if the C flag has been passed. I didn't bother with that functionality for half the languages. Like Python and Lua, reading bytes and decoding was straightforward, and .io is a nice short way to get a file handle that I found nice for scripts. Raku supports this somewhat strange syntax for argument passing using colon, but it does feel good to write, and I like the way it looks. Postfix if also feels really good. It sort of reads like English, which I think is a big goal of Larry Wall in his language design. It's certainly fun, but I'm not sure if it's the best for maintainability. I have no data for this though. You would expect a Perl-based language to have good string handling, and this does with lines, words and chars. LMs gets the length of a collection. The printing uses a similar method to Python, except we use a string join here. Raku gets a 7 for easiness. The language has a lot of syntax and it can get a bit complex at times, especially when you're learning it. You do need to embrace the motto of there is more than one way to do it and not stress too much about getting things perfect. I also never got the -m flag to match the WC program, but the count it gave did match Emacs, and I know that Raku put a lot of effort into Unicode handling, so I'm inclined to believe that this is correct. 7 for documentation, mostly because it's so complex. It's a similar reasoning to the easiness. There's a lot of documentation, it's well written, but picking out exactly what you need can be tricky, especially amongst the characteristic noise of a Perl language. It gets a 9 for enjoyment. What makes the language complex also makes it really fun to write, and this doesn't even scratch the surface of Raku when you consider things like whatever and sequences. I think I'd like to make another video on them at some point. Along with Lua, Factor is a language I've never used before, and I'm completely new to 4th star stack-based concatenative languages. I found this pretty brain-melting to write. I was seeing stacks everywhere in my life for days afterwards. The parts in green are stack effect notation. They're checked by the compiler so you get some assurance that what your word is doing is correct, and I did spend a lot of time working around them to get the program to compile. Stack effects essentially say what you expect on the stack before calling the word and what they'll leave on the stack afterwards. The question marks here denote booleans. Combinators like rot, swap, dupe and drop here are everywhere in the language and make you feel like a genius when you get them right. I'll leave a link in the comments about combinatory logic. It's quite an interesting topic. The square brackets denote quotations, which are essentially lambdas in some cases and kind of like blocks in others, but they're easy to get to grips with. It feels like the language pushes you to do one-liners, which makes the code feel really elegant. Having said that, Factor becomes a lot easier when you use the double colon, which allows you to bind the symbols in the stack effect to local variables. It doesn't feel as elegant, and my switch to them felt like conceding a battle, but I think it's more maintainable, and I did notice in a few cases the documentation was pushing you towards using these. Suffix appends to the list and returns it, which is why we have drop at the end of each of the lines. That does mean that on the second last line the drop could be omitted since we add result to the stack at the very end anyway. The code in the quotations in the last block is what actually does the counting, and I think it's fairly straightforward to read. There isn't really much code at all to do what we want. Partition is a built-in algorithm which takes a predicate and puts 2 sequences on the stack as a result. One sequence is the elements where the predicate is true and the other false. This made the command line argument handling feel extremely elegant to me. Getting bytes wasn't very hard, but it did take some time to figure out. That was just my fault though. I got confused between encoding and decoding. I never seemed to be able to get that right. Reading the file was extremely straightforward. We passed the list of non-flag arguments to first, which takes the first element. We set the stream to binary mode and then just read the file contents. Then whatever bytes we've read from either stream gets passed to count stuff, which you saw in the previous slide. We have an example of map, which is extremely simple syntax again. We're just converting each number in the counts to a string so that we can print it. This uses the string join method as well. The second to last line felt a bit complex for my level, since the stack going into the if condition was a variable length depending on which branch you take. I was very pleased with myself when I got it working. Factor unfortunately gets a 1 for easiness. I'm sure I could bump this up in the future with a bit more practice, but it was so new to me that it has to be a 1. The whole program took me about 12 hours to write and I was pretty sick of it by the end. 6 for documentation is probably generous. It's pretty much impossible to search for answers to issues, but the Discord is actually quite active. There is a lot of documentation and you can tell a huge amount of passion's been poured into this language. They just need more examples, and being able to search by stack effect would be nice too. I'll mention something that Haskell has which would work well here. It gets an 8 for enjoyment though. The programming environment's really nice. Unit tests were my favourite implementation of any language I've used, and it's really easy to get started with the REPL. I like the interactive style development, and my favourite feature is that they tell you to work in your own editor and then periodically compile in the IDE. The integration does feel really good. It also has a very well featured standard library with networking, JSON, and even a GUI library, which is kind of mind-blowing to me. On to Racket, a language that I've enjoyed writing a little bit of in the past. Command line form was really fiddly to get working, and I found it quite frustrating, and it didn't even work properly in the end since I couldn't get permutation working. The args keyword argument is documented as being destructible or taking a list like above, but it seems the only way I could get it working properly was to name them args like I have in the define in the first line. If I used something other than args, it didn't seem to work properly. This behaviour didn't seem to be documented. I shamelessly copied this recursive standard in read from Stack Overflow. The idea here is quite elegant, and with Tailcall optimization it should be somewhat efficient too. Reading a file, however, is very standard and similar to how most scripting languages would do it. There's 3 snippets here. The first one shows the boilerplate, which each of the counts used to build up a result list. The second shows each of the count calculations. These are very straightforward and similar to the other languages we've seen so far. Third one is how we print, once again using a string join. I do like the arrow syntax here that you can see in number to string, but it does get quite verbose at times. And this also goes for the non-polymorphic forms like string split and string join. There are dedicated functions for each of the primitive types. In a dynamic language, non-polymorphic functions feel quite bad, and it's easy to make mistakes. I feel like I've been a bit harsh on Racket here, but I didn't really enjoy the experience. The majority of the time I spent writing this version was on the command line argument passing, which tainted the whole experience and made it feel really bad. In hindsight, if I had implemented it just like I had in the other languages like Lua and Factor, it wouldn't have been bad at all, and I don't think I'd have much bad to say about the language. Having said that, I don't think Racket is well suited to this kind of program, despite the broad ecosystem and standard library. Another Lisp here is Clojure. This one somewhat benefited from not having a command line API, so we did it in the simple way. It's not really fair to Racket, since they lost points for providing more functionality. Clojure provides a contains function where you can check if an item is an element of a list, but that doesn't work on the type that command line arguments is, so we have to use this sum and then check whether it's nil or not. Also, I'd like to say that I really like this variadic OR that Lisps have. Racket has this too. It just reads so elegantly. This was my favourite of all implementations for either reading from a file or from standard in. Just look at it, I think it says it all. This is as simple as it gets. Beautiful. The Clojure here contains the control flow, just so you can get an example of what most of the languages are doing. I do like the use of when, which is common in functional languages for a branch with no else condition. S/ is the Clojure string library. This provided good functionality for working with strings. Same as Lua, we can pass a string or a regular expression for splitting. A-length and get bytes uses the Java API for representing a string as UTF-8 encoded bytes. It's nice that we can lean on Java, which keeps the core language small. I'm getting Lua vibes here too. Printing's the same in Racket and most of the others with a string join. Perfect 10s for Clojure across the board. It seems to strike the balance of practicality and beauty really well. Generally speaking, I do like the language, as you can probably tell, so I am a bit biased. I don't write it very often, but I'd like to use it more in the future. First up, I want to say for Flix, I'm sorry to anyone who knows this language. I think I probably did a really bad job of implementing this, and it was one of my first attempts, but my bad code didn't put me off the language. There's 2 snippets here. First is an abbreviated example of how you define the data format for a single command line argument. This is required by the GetOpt API that the language provides. I do like how they've put some effort into the practicality there. Pattern matching seems to turn up in the language a lot. I got the general impression that if you had a lot of match statements, code was probably bad or inefficient and there's a better way to write it, but I don't have enough experience to see the alternatives yet. I also like that they provide a pipeline operator. This code omits quite a lot of ceremony required by the GetOpt API, so you're just seeing the good bits. Regions are explicitly stated blocks which give you a scope to access memory, kind of like an allocator. I do think this is a nice idea compared to RAII, and I'd like to see it in a few other languages. The region gets passed as an argument to subsequent function calls which want to write to the region, like you can see in file.readBytes. I like that the data pipeline here is clear, with bytes being passed into the counting function and then to the list join. Obviously this code could be refactored a little bit, since there's a lot of shared behaviour between the standard and file implementation. Here's an example of Java FFI in Flix. Like Clojure, we can lean on Java's standard library, which makes the language have a lot more potential. The Flix type system seems quite powerful, and it's nice that it maps well in the FFI. You can see an example of using a region as an argument in read standard in, even though it's not actually used. I'm not sure if this was required, but I needed some way to get the type into the return value, as read all bytes writes to the region. I really like that they provide a lazy keyword for delaying evaluation of an expression. This means we don't need any control flow here, and we can set up each expression even if we don't need to calculate it later on based on the command line arguments. The type of decoder here is an option string, which is why you see option map everywhere. This is because decode is none if you don't pass the C flag to the program. For each yield is basically a list comprehension, and force evaluates the lazy expression. Filter map identity extracts the values from the options for our result. Due to lack of experience with functional programming, I found Flix quite hard to write, plus it's a young language so there isn't much learning material around. Documentation will grow as the language does, and what's there is quite good, even though I do remember having some issues getting FFI working, and naturally it could always do with more examples. I do think 7 is lowballing it for the enjoyment really. It definitely is a nice language. This is another case like Racket where the language will shine in other areas much better than it would here, and I'd like to use it in future videos too. Having said all that, it is practical enough to get a program running nonetheless. Now we have another functional programming language, Haskell. There's 3 snippets here. The first one is the flag declaration like in Flix, but considerably more concise. 2 shows a little bit of how you use GetOpt. I wonder if the Flix API was inspired by this. It does look rather similar. The third is just calling the argument pass function and assigning it to a result. Args is a list of flags and files is a list of strings. 2 more snippets here. Pattern matching in Haskell is really elegant. I like that you can use it in function declarations. We pass a list of files from the argument passing into read input. If none were found, then we have the empty list and we read from standard in. Otherwise the list is non-empty, so we take the first file with head and read it using readFile. Needs decode as a simple predicate function which checks if any of the arguments aren't bytes. If they are, then we need to decode the byte input using the standard text module. If we don't need to decode anything, we return an empty string, although I could have used maybe here similar to the Flix implementation. Once again, we're making use of pattern matching in the declaration of the count function. Having to pass the byte string and the text at the same time felt like a bad design choice, but it did work. I like that you can branch without the ceremony of if conditions, and it gives you a nice declarative result. We use a list comprehension to gather our counts. We do this by mapping each of the arguments we have provided to f and then calling count stuff. Put string is the same old build a string from a list joined with tabs and print. Haskell surprised me with how easy it was to implement given its reputation. It did have some minor issues with IOString, and I think this is pretty common for people who are new to Haskell, and a little bit of problems with the command line arguments, but it wasn't too bad. There was decent documentation on this. Haskell's secret weapon for documentation and why it gets a 9 out of 10 is for Hoogle. This allows you to search by function signature. I wish more languages had this. This was what I was talking about with the factor stack effects. I gave it a 9 for enjoyment because of how it surprised me. I enjoyed that it wasn't a frustrating experience to write in such a powerful language, and the fact that I was dreading it beforehand. C# seems to have a nice well thought out API in general. The Fluent function calls are easy to read, and the intent is clearly stated. The language gives you all the bells and whistles you'd want in a modern application programming language. Reading standard in is the case that kind of betrays the broadly nice API. This is why doing a practical programming challenge is useful. It feels like there should be an analog to file.readAllBytes for standard in, but instead we use an implementation similar to Lua, where we read the standard in blocks. Decoding the string has that very enterprise feel, but I do like how it clearly states exactly what we're doing. String split, however, is a case where the API is nice. It does look like it's overthought at first, but I've had a few problems with some of these implementations in getting the results exactly correct, and there's a lot of flexibility here, especially with string split options, where we can remove the trailing empty line. I hope that this made this count more efficient. However, for the word count, split didn't work and I had to fall back to regular expressions. This unfortunately meant that I had to trim the string, so we lost any efficiency gain we got from the line count. I'm sure there must be a better way to do this. C# loses 2 points for easiness based on the standard in handling, which got a bit fiddly compared to what I felt like it could have been. Documentation is superb, however. The official docs and the availability of resources are incredible. This could have been a 10, honestly. I do find it's very enjoyable to write given the maximalist nature, and I can see why so many people use it in commercial settings. It also has excellent debugging support. Go has a pretty nice command line API too, similar in principle to Python. After you call parse, you just dereference any of these CLMW variables to get the value from them. We get the number of remaining command line arguments with narg, and then if there are any, we take the first and read from that file. Otherwise, we just read from standard in. This is exactly the API that was missing from C#. The result shows you how to create an array with capacity. We're only ever going to show at most 3 counts, so we're being extra efficient here. The final statement shows how we convert to a string from bytes. There's no mention of decoding here. This is how I implemented the line count. It works the same as C#. It's just unfortunate that we had to use that trim again. Here are the rest of the counts, just using simple lengths. Strings.fields seems like an unintuitively named function for splitting a string on whitespace. I have to assume it's primarily used for something else. Graphemes are called runes in Go, so we have the rune count in string for that character count. Printing the list of results is a very hacky approach I got off Stack Overflow. I'm sure Go would prefer a plain loop instead, and I think I do as well. Go was pretty easy, barring some strangely named functions. For my level of exposure to the language, it was very quick to learn. 7 for enjoyment is probably harsh, but I didn't find it as engaging as some of the other languages for this project. Hax is another language that doesn't come with a command line parsing solution, so we go for the straightforward array contains. I kinda wish I'd just used this for all the implementations really, even though I did get some interesting insights using the alternative. If you run in interpreted mode, sys.args contains the arguments passed to the compiler as well, which is annoying because it doesn't simulate the runtime experience. This meant that I was always compiling the code. To reduce the feedback loop time, I compiled to Python, but for the release mode I did target C++. This is an example function in Hax. I think it's pretty self-explanatory. Reads a bit like Java. You can't use the square bracket operators for indexing into a string and have to use char at instead. At least it had reasonable error messages for this. The reading portion was similar to Go here. I liked that there were 2 simple ways to read bytes for both use cases. This was one of the nicest, if not the nicest language with respect to getting bytes from I/O. Overall, it seems like a very straightforward language, which probably makes it nice to use in production. String tools is equivalent to the Clojure strings library and is provided with the language itself. This was useful, but it's unfortunate that we suffered the same issue as C# and Go, where we have to trim the text to get the count correct. The rest is the same as the other languages. Hax seems like a language where you just try things and they work, which is a great trait for getting things done. Documentation is pretty good, but searching is quite bad because you can't search by function name, and the documentation pages don't summarize each module with a table of contents. The standard library is well featured though. One aspect I didn't like about Hax is how you give the compiler a class name rather than a file as an entry point. I did take a look at the Python output and it was actually quite readable, which surprised me. I also tried targeting the Lua backend, although that didn't work because it relied on a library that I didn't have installed. I've never written Ruby, so Crystal's my first foray into this style. It has a very nice standard library including command line argument parsing, probably the most elegant of all of them in terms of API design. I like that, unlike some of the other languages, unknown arguments can be explicitly handled to get our file name. I was a bit confused about how to implement this at first though. It isn't emphasized in the documentation. I think this caused the Crystal implementation to be the most resilient one. It was the first language I implemented for this challenge and it set the bar high. I did find a from stdio function in the documentation that sounded promising, but the link forward, so I found gets to end via Google. Note the gradual typing. I've omitted a return type here. Not intentionally, I think I just forgot. The implementation here is pretty much as nice as Clojure, not much typing at all. I personally like the optional brackets on function calls, although I know a lot of people don't like that. Question marks in identifiers to signify booleans or predicates is very nice too. I had some troubles with the nil dataflow analysis. You can't use it at top level and must have it in a function. This is by design due to the possibility of data races, and this is documented clearly. It provides some sugar for appending to an array, even though it's a bit unnecessary. It's always nice to get fancy sometimes. The count calcs are on par with Python here. Pretty much as nice as it gets. Not much else to say other than I really like this code and this language in general. I found Crystal to be very nice to write, and since it compiles to LLVM, has really good performance too. Gets a 9 for documentation since I wish there was a table of contents on the documentation pages. The dev builds in Crystal are okay, the release builds are quite a bit slower. Crystal also has an experimental interpretive mode, but it crashed when I tried to run it due to the option parser failing, with an internal compiler error. D feels like a very flexible language. HasFlag is reminiscent of the C# style, with a fluent API. D supports UFCS, so canFind isn't a method on a string array, but instead a standalone function. I personally really like that style too. The $1 syntax is array slicing, and the final use of hasFlag shows another case of UFCS, since we haven't defined hasFlag on a type. This is pretty much identical to the Hax version. The exclamation mark is how D does template instantiations. The predicate function parser filters template is compiled efficiently rather than passed at runtime like a Clojure. That said, it might actually be a Clojure. I'm not an expert on the semantics here. We have to read standard in chunks like C# and Lua, but the API is quite a bit simpler since we can just call array join directly on the chunks. Here, instead of reading bytes from standard in, we cast it to a string since we're using read text, which reads decoded text from a file. We don't need to load bytes since we can do two different kinds of length on the string by counting either bytes or graphemes, exactly like Go's rune count in string function. I do wonder if reading text would have been easier and the best approach for all languages, instead of fiddling around with bytes and decoding. The counts once again are similar to Python Crystal. The tilde equals is how you append to an array in D. Decode seems to have a similar API style that you commonly find in dynamic languages. I think this is becoming more of a general trend though. Maybe it's just the optional parentheses on calls. Walk length counts the graphemes in the string. This is D's version of the rune count in string function from Go. On the final line, map shows another template instantiation like the filter before. The map itself just converts the numbers in the array to a string. Then we do a string join, like all the other languages. Perfect 10s for D2. The language feels really well put together and the doc is also very good. I've also found the community to be helpful and knowledgeable in the past. Another bonus is the code tends to run pretty fast too. Nim is another language which gives us a getopt API. I think this is one of the better ones, especially among the statically compiled languages. Have I said that about all of them so far? I like how Nim supports pattern matching, and we can exhaustively check the kinds of each argument. However, I'm not sure if there's a bug with the inner case, since we only check 4 strings. This doesn't look exhaustive to me, but it didn't give a compiler error. This version lets you write the parsing yourself by iterating over the arguments manually, versus the Crystal version which handles it all for you. I do think both approaches are good. It should come as no surprise that I like the fact that Nim provides read all for standard in and files. Nim almost nails the elegance of D and Crystal in terms of the counts. Unfortunately, strip line end was required to match the line count given by the real WC program. If count lines could take some C# style parameter, where we could ignore the end, that would probably run faster. Because we modify the text in place, count lines has to happen at the last and be inserted into the front of the results, because the output expects the line count first. The ampersand is string interpolation in Nim, and this is provided by the standard library, not built-in syntax. Also note the optional parentheses on function calls. Nim is a great language and very fun to write. It loses 1 point on easiness for the strip line end workaround though. The layout of the documentation didn't feel quite as good as D to me. I think it's probably a bit harsh to lose a point for that. Finally, we have Pascal. This language uses begin and end instead of braces for blocks. I think they're optional, which can actually lead to some decent results in control flow like you can see with the if statements here. There doesn't seem to be a return keyword, so we use exit instead, which does the exact same thing. I think these two functions are very readable, and I'm perfectly happy with them. We use procedure to declare a function that doesn't return a value, and function if it does. Pascal is another language that has optional parentheses on function calls. For example, EOF is a function. There is a function to read blocks from standard in like the D version, but readline seemed to have a nicer API and was easier to use. Pascal is a rare case where the standard in read actually seems nicer than the file read. I really do like how you declare variables separately to the main scope of the function. One thing to note here is that the contents variable is a global. The syntax, where we have a hash followed by a number, is how you write characters. I didn't actually check to see if there was a way to write the letter instead. Word count is a built-in function that is actually more efficient than most of the other languages, which have to do splitting then counting. It was nice that it provided exactly what we needed here. It also has UTF-8 handling courtesy of libraries provided by Lazarus, which is the free Pascal IDE. Technically it's not in the standard library, but I think I'll give it a pass, since it will be always available. One final note on Pascal is this comment which enables long strings. If you don't write this in your program, all strings are limited to 256 bytes in length. This was a source of confusion for a little bit. Pascal is another language that surprised me honestly. It's not as expressive as some of the modern languages, but it's definitely nicer to write than C. Nothing really tripped me up at all. Getting the actual calculations right was one of the easiest of all the languages. Getting the LazUtils library, which provided the UTF-8 support, to work was a little bit tricky at first since I was using the FPC compiler directly and not using the IDE, but it was trivial once I switched over. So, take this with a big heap of salt. Since the implementations differ between all languages, I didn't write them to be efficient, and I only tested with one input and one set of arguments. Standard in wasn't tested, and neither was UTF-8 char counting. Having said that, I think projects like this are always more fun when you see some benchmarks. I've left out some of the outliers since the graph looked better without them. Safe to say if the language isn't here, then it ran really slow. Pascal is impressive, but it did have the most efficient implementation, even if that was unintentional. Crystal wasn't written as efficient, but still very fast. Haskell's also showing here that functional programming is no slouch. Python, Nim and Go definitely feel like the outliers here. I'd have expected the latter two to be faster, especially with Python beating Nim. I went back and had a look at this, and the word count seems to be the slow part. Perhaps I'll revise the implementations and do some more tests. Lua and LuaJIT being equal shows that we're IO bound, which is obvious but interesting to see. C# matching Go feels like quite a win since it has a bigger runtime to spin up. Hax performed pretty badly, which makes it less appealing than some of the other similar high-level languages, especially since it's quite niche itself. Flix wasn't fantastic, but I'm not sure if I compiled it right, and I'm not very familiar with the JVM ecosystem. And for a new language, it's not too far behind Clojure. Clojure could have been faster if I compiled it to a jar, but I wasn't sure how to do that with a standalone file, so I just ran it with Babashka instead, which is based on GraalVM. Raku has a bit of a reputation for being slow, but I did expect this to be worse. Factor was disappointingly slow since it's compiled, but I'm pretty sure I wrote a very poor implementation. I included HaxPy just for a comparison of the sort of overhead you can expect versus handwritten Python. It's quite the hit, and I wouldn't say it's viable outside of niche circumstances. For the languages that got compiled, here's a list of the binary sizes. Even though I'm sure no one cares, binary sizes always meant a lot to me since I used to program on a $100 laptop without much disk space. Nim's seriously impressive here. I never understood the criticism of compiling to C. It's a clear win, and that's statically linked as well. Haskell's statically linked binary, however, is seriously huge at 25 megabytes. You can dynamically link it, as shown by the Haskell dynamic, but it gives you a 10 to 15% runtime performance cost. Both Crystal and D were compiled with LLVM, and I'd say that Crystal does put up a decent fight here. 350 kilobytes isn't too bad at all. I would say anything over a megabyte is very bloated. I do wonder if Flix's runtime performance was influenced by the size of the jar it produces. It feels like getting an 8 megabyte binary up and running can't be very efficient. Racket actually managed to get on the list here, but I don't think that's a good thing. 60 megabytes is on another planet. The line counts aren't an exact science since formatting varies between languages, but it's still somewhat interesting. Most of the languages came in around 40 to 50 lines. I'd say anything around or below 40 is good going. Raku, coming from pristine scripting lineage, puts everyone else to shame here. Flix looks rather bloated. Some of that's due to the FFI boilerplate, but I think the implementation is bad too. Lua suffers from a similar issue where you have to implement common functions by yourself because the language doesn't provide them. And that's it for the challenge. I hope you found it interesting and learnt some new things about various programming languages. For me, I found it to be a good learning experience and an excuse to try fun new things. I want to add a caveat that I didn't showcase the best of the languages here, but it was somewhat decent to get started. One takeaway I have is that I need to get better at functional programming. I'd like to put a lot more effort into this in the future. Finally, there's more to life than JavaScript. If you have any feedback, I'd be happy to hear it. I feel like there's still lots for me to learn about a lot of these languages. The repo is in the description if you want to improve any of my attempts. Pull requests are welcome. Thanks for watching.